Hey everyone, so I'm going to go through in this video how to change your Lab 1 VI that you already have to be set up for Lab 2. So first thing we're going to go ahead and do is save our Lab 1, do save as, substitute copy for original to make a Lab 2 VI that's different, just so that if we mess up we can have something we can go back to, and just so we have Lab 1 the same way, since we'll probably modify it again for Lab 3. So for this lab, we are done with closed loop control. So I'm going to go ahead and get rid of our whole case structure here, as well as the error calculations. Delete, and I'm going to just go ahead and get rid of the wires. So then you can do Control B, and that will delete everything else that we already have. So for this lab, we are going to be still using our sine generator. So only difference we're going to have is our magnitude. Instead of being between like negative 150 to 150 in degrees, we're going to just set it to be between -1 and 1, as it's going to be the motor output that we go to the H bridge. To make sure that it's always between -1 and 1, we're going to go ahead and add a in range and coerce. So just right click and search for it. Go ahead and grab it here. So we already have our desired, which is going to be our command out. I'm just going to go ahead and rename that. So I'm going to drag this wire into the center of the in-range and coerce, and then on the bottom, right click, create constant. Not -41. We're going to do -1. On the top left, the upper limit, right click, create constant. We're going to do 1. I'm going to go ahead and right click on the actual item and do include upper limit, just so that 1 is inclusive. And then we can go ahead and run this coerced X up to our H bridge, since this is the command that we're sending our motor. You can see, like I said, we're not doing closed loop control anymore, so what we tell the motor to do never looks up here at what our actual flywheel is doing. But we are still interested in what that flywheel is doing, so we're going to do some things with that now. We're primarily interested in the velocity of the flywheel, since that's what our transfer function is going to be in. So to get that velocity from position, we're going to do a math tool higher order. So I just right clicked, select a VI, and then in the class library, if you go to tools, it's right here, math tool higher V. Go ahead and put that in there. I'm going to just go ahead and click it and do Control H, and that's going to let me see what all the different connections are. So time, I'm going to just go ahead and grab the elapsed time that we have going into our frequency generator and hook it up to that top left node. For data, we're going to do the current position of the motor. So that's going to be this top right element here. That's just coming from the encoders, again, on the actual flywheel motor. We're going to be taking the derivative of position to get velocity, so we want to be able to control how many points we take that derivative over, or how many we approximate it over. So I'm going to right click on this bottom one, points to differentiate, and do create control, and we're going to just leave that for right now. And then lastly, I'm going to put on first derivative, I'm going to right click, create indicator, and I'm just going to name that velocity, just so I know what I'm connecting to everything. So that should be everything that is new. We want to go ahead and get things set up to save. So we're going to put the motor's current rotation angle. So we already have that here along with elapsed time, so don't need to worry about those. The motor rotational velocity. So I'm going to grab this wire, poke it through the side, and go on that top element. We want the frequency, so our frequency is over here. Again, just click on the wire, and you can click however you want it to route, and put that on the second one. We want the magnitude, so that's what we're telling it to do. So that's going to be right here. It should stay at pretty much 1 if you're doing the sine sweep, but this is just to make sure that you didn't make a mistake whenever you're looking at your data. And then finally, we want the controller command signal, so that's what we're actually sending to the H bridge. I'm going to go ahead and put the coerced, but I'm going to need one more box. So again, just hover over the bottom and drag it down to get an additional save spot. And then just connect a wire. And so we should be good. So again, you can see left, we have a solid white arrow, so that means nothing's broken. If we switch back to our front panel, we have our new points to differentiate over, which I'm going to just go ahead and drag down. This is going to be somewhere between 3 and 5. I'm just going to put it at 4 for now. Our phase offset is going to be 0 for this lab. The magnitude, like I said, is going to be just 1 because we want it to go between -1 and 1 on our command. And then our frequency, you're going to just change based on what one you're interested at the time. I believe the lab document says you're going to go through about 20 of them from 0.05 hertz all the way up to 26 hertz. Last thing, before you go and do that sine sweep or the step response data, just go ahead and double check to make sure that your flywheel is tight, as if it's loose, it can really mess up your data. So anyway, that's all there is.